Thank you, everyone. Can everyone hear me okay? Awesome. Okay. Sylvan, thank you so much for the invite. I'm happy to be in Paris, and I'm more than happy to be talking to you guys about this. This is actually my first talk about GeoSpy, so super excited. So, uh, for those of you who don't know what GeoSpy is, as Sylvan said, it is a GPS prediction AI platform. It's free, anyone can use it, and it allows people to upload photos and predict GPS locations from the pixel data inside the photo. So no metadata, no IP tracking, just simply pixel data. So the title of my talk is aptly No Metadata No Problem, Predicting Photo Locations from Pixels Using AI. For anyone who doesn't know me, who am I? My name is Daniel Heinen. I am the co-founder and CEO of Graylark Technologies, aka GeoSpy. I originally am from Boston, and my background is in applied AI for defense tech, so mostly drones, autonomous systems, that type of thing. And I'm kind of a US-based hacker originally, so mostly I used to do a lot of reverse engineering IoT devices. And if you're ever, does anyone here go to DEF CON in Las Vegas? I guess. Yeah, there we go. Awesome. So catch me at IoT Village anytime. But so that's kind of my background. So why am I here? That is a great question, and I find myself asking that every day. Why am I here? But really, the answer, funny enough, comes from Reddit. So why do I say that? About 7 months ago, I was reading a research paper from Stanford called Pigeon AI, which basically talked about a novel method for doing this type of image geolocation prediction. And it was very heavy and very mathy, and I thought it was really interesting, and I went to go look for a GitHub repo. I wanted to test it out myself, and there was no GitHub repo. So me being a hacker, I was kind of mad, and I was like, well, I want to try this out. So I basically spent a lot of time reading the paper and trying to understand how it worked. And I put together something that worked, and we'll talk about that later in the talk, how it actually works. And I just posted it on Reddit, and I thought maybe a few people would find it interesting. So this was my original post. I essentially was saying, hey guys, I built this free tool where you can do GPS predictions on photos. Let me know what you guys think. This is kind of what it looks like. I don't know if you guys can see that. So essentially, it's a free website. You just go, you drag and drop, and it gives you a prediction. So does anyone know where this is? Does anyone have a city guess at least? So, okay, we'll get there in a second. So I took this picture yesterday, and when you upload it to GeoSpy, you will see you get a city, country, and a description justifying why it thinks that. So this says Paris, France, and there's a GPS pin. And so that prediction only comes from the pixel data. So essentially the photos are base64 encoded, uploaded as a string, and then we perform a prediction. Um, so how accurate can this be? I think it's a good question, right? So you're just uploading a photo somewhere. There's, pixels in the photo. Is this prediction method accurate at all? And depending on the quality of your photo, so how the lighting and how good it is, they can actually get extremely accurate. So here you can see a very low context photo taken on a boat somewhere. And this is about maybe 5 kilometers, the top prediction from the actual location, which I think is really interesting. And so here, this is our GeoSpy Pro. This is a reserved for kind of approved users, law enforcement, etc. And this is still in development. But this shows when you have a lot of training data and a high quality image, you can actually perform really accurate GPS inferences. So what is the point of all this? Why does this really matter? So this is a kind of a subfield of geospatial intelligence, which is essentially analyzing images, whether it be satellite or user-generated images, to learn something about a certain location. So what is this used for? As many of you might have guessed, there's a lot of applications in military, defense tech, disaster relief, police investigations, etc. So the idea traditionally before, most of this kind of geospatial intelligence was reserved for government, police, people with satellites, all these types of surveillance systems. But more and more, this geospatial intelligence and open source intelligence have kind of had a nice combination. So I'll give you an example of why this is kind of relevant. So is anyone familiar with the Russia-Ukraine war? Probably. So One of the most interesting things about this war and war in general in the modern age is the fact that over time we've seen these platforms like Twitter, TikTok, Reddit, Discord, Telegram, where real-time events are unfolding, and instead of just lexical, words describing what's happening, there's photo, video, and audio that's coming out. And so what's really interesting about this is we can see events happening in real time. And the only problem with that is most of these platforms strip the associated metadata. So I think most of you probably know what metadata is, but just to recap, sometimes if you take a photo on, say, your iPhone or Android, it has a GPS in your device, it'll add a tag. Most data platforms, Instagram, Twitter, TikTok, they take those tags out for privacy reasons, which is a good thing. But what happens is that we lose one set of data when these new real-time events are happening. So someone posts, there was a missile strike 3 minutes ago, or I saw something here. We don't actually know where to verify where it is. If we're collecting data and we want to understand a region, we don't, we have to go by either location tags and trust that, or just word of mouth, hey, this was seen here. So this type of applied AI for predicting locations has huge implications when it comes to real-time intelligence, journalism, etc. So the same thing can be said for fake news. So I think we've all heard about, with upcoming elections across different regions, different countries, there's a lot of fake news and disinformation that happens where people will take old photos or photos from different events and ascribe them to current events, whether it's protest, a missile strike, etc. And so these types of disinformation campaigns can be very powerful because it's very difficult to prove where something was or give users an easy tool for figuring out the origins of an image. So something that I get asked a lot is, how does this work? So most people, when I first started this platform, told me straight up, you're using metadata, this is impossible, and you're lying. And, there's a lot of that. Most people just did not believe that it was possible. And I had to over and over again say, there's no metadata, you can try it, you can spoof the metadata. And I had lots of people tell me I was lying, and I was like, okay, go spoof the metadata, and they did, and they still got the right location, and they're like, okay, you must be tracking my IP address. And then I was like, okay, well, I can't really do much for you. But the point of my talk today is to give you guys some background and to help you understand, we like to use the words AI, it's kind of a big buzzword, AI machine learning, but today I want to teach you how the first version of GeoSpy came to be, how it works, and how you can build your own version of GeoSpy. So first, a little bit of background. This graph here shows the history of this type of photo geolocation technology. So I'd like to say that I'm the inventor and I came up with this concept and I'm super smart, but actually this work started back in 2008 under Dr. James Hayes when he was at Carnegie Mellon. He's a great guy and one of our advisors now. So he pioneered the concept of taking photos and being able to accurately predict the geolocation. His accuracy was about 30 times higher than random chance, so not very good. That started in 2008. Fast forward to 2023, there have been a lot of research papers. Has anyone read any of these research papers? Exactly. So that's one of the reasons why I wanted to start to make this technology accessible for everyone and the purpose behind GeoSpy. So the most recent paper that came out coincides with new technology that we'll talk about in a minute. But if you see over here, the newest paper, kind of in green, is Pigeon AI. That paper came from Stanford in 2023, and that was the paper that inspired me to start GeoSpy. So before we start talking about data, the most important thing that we should talk about is before we start talking about AI, the most important thing we should talk about is data. So in order to train any AI to be good at this type of geospatial prediction task, we need images with metadata. So we need an image with an accurate geolocation for reference. Now, I was just talking about how most of these platforms strip all the metadata. So how do you build an accurate training data set if Instagram, Twitter, etc. strip all the location data? So the answer was given to us, as I said, in 2008 by Dr. James Hayes when he realized that you could scrape lots of data, millions and millions of images from Flickr. Has anyone used Flickr? Anyone familiar with that platform? So for those of you who don't know, Flickr is kind of an older precursor to Instagram, where essentially they allowed users to create photo albums, upload photos from around the world, and if your phone or DSLR camera had a GPS in it, it would include the metadata tag. They had this neat feature where you had this map where you could explore different photos taken around the world, and it was really cool. So why that's useful for us is because that was one of the few ground truth sources for data with GPS tagged information. And there were about 100 million or more, I think it started in 2008 with 100 million. But there were about 100 million images originally when this work was done with GPS tags, and most of them very accurate. Obviously, some of them spoofed or default to 000. But, for the most part, there was lots and lots of interesting information. And if you look here, you will see that there is a bias towards more populated areas. So obviously the United States, where, where these mobile devices, GPS tag things really kind of took off first, and then Western Europe, etc., a little bit in Asia, not so much in Africa. So these highly dense and kind of more developed regions tend to have higher concentrations of images, and we'll talk about that later. So what's happening today that made this possible? So I talked about the work Dr. James Hayes was doing back in the day, and when he was doing his image geolocation prediction system, I think it was about 16% of the photos could be geolocated within 200 kilometers, which isn't very good. He was using very simple techniques like matching pixels and essentially taking similarities in pixel colors and matching them to others. So has anyone heard of AI, ChatGPT, this type of thing? Yeah? Okay. Does anyone know the kind of technology that made all this possible? Anyone? Okay, we'll talk about that in a second. I want you guys 1 second really to kind of notice. You see, I don't know if these colors are very clear. You see how there's this image, and then you can see these kind of highlighted patterns on the image. Take note that certain features in this image, like the ticks in the road or the electric pole, are highlighted. What that's telling you is that these have kind of a weight to the decision that was made. And the reason that's relevant is something that you might find interesting is most geographical areas that have man-made structures, as well as natural types of structures, tend to be different. So in France, for example, the electric poles and road signs are different than they're found in the US versus China, etc. The same thing can be said for soil types, the type of terrain, vegetation, etc. So that's important for later. So the technology that backs ChatGPT, etc., is this type of deep learning model called transformers. That could be a whole talk by itself, but essentially these were invented by Google DeepMind, and then OpenAI essentially took this paper and they turned it into a huge product, and now they're worth many, many billions of dollars. So I guess read the papers that come from Google, and maybe you'll be billionaire someday. So lots of people are interested in transformers. Who here has heard of a GPT or GPT-3 or ChatGPT? Okay, a couple people. So there was another model that OpenAI came out with called Clip. Now, how many people have heard of Clip? So I don't see many hands raised, and I hadn't either. And so I actually think Clip is more interesting and more relevant than these type of GPT models. And so the CLIP stands for Contrastive Language Image Pre-training, and it's a type of zero-shot classifier. And what that means is essentially what they did is they took 400 million images and 400 million image captions, and they trained a model that basically understood how you connect language to text. So, maybe they took a picture of a corgi and they said, cute corgi, and you can kind of imagine from there a man in a brown shirt and a picture of a man in a brown shirt, and they did hundreds and hundreds of millions of these images. And so when I say zero shot classifier, essentially what that means is you can upload an image and you can have them, and you can give it a list of what are called classes. They're just simply words, and you could say, hey, which sentence or word is most likely associated with this image. And so before we go on, I guess the question is, why does that matter? Who cares? How is that relevant to OSINT? So I have a question for you guys. What is this? It's not a trick question, I promise. Yeah, exactly. So I heard someone say a building. So if we take this clip model and we ask it, what is this? Let's see, can we see this? Oh, sorry. There we go. Okay, yeah. So we give it a couple different options. We say building, apple, cat, dog, and it very confidently says this is a building. So this model was not trained to classify buildings versus cats or dogs. It essentially learns to understand what natural language is associated with those images or kind of the pieces, the features in an image, and it can do something like that. So let me ask you a harder question. Where is this? I'd be very surprised if anyone could guess. Does anyone know? Nope. So something interesting that researchers realize is what if we take that question and we ask Clip, where is this? Now, this is kind of a weird concept because, again, Clip was never trained to locate images. But if you think about it, if anyone's ever gone on Google or any of these types of things, images tend to have these captions online of where they are. So City Hall here, this building here, they'll have usually a city address, etc. So let's start with something simple, and let's use countries. So we're going to give Clip a couple different countries or regions, and we're going to say the Americas, Africa, Asia, and Europe. And lo and behold, it gets the first thing right. So this building is actually in America. And that's really interesting. And so the question you might ask is, well, how does it know that? So would anyone say that French architecture tends to be recognizable as French architecture? Yes, no? If you look at a building or you're in France, you're like, okay, I'm in France. Same thing with England. Maybe the United States is harder because they're kind of crazy with their architecture. But essentially, that's the thing. So this model has learned by looking at hundreds of millions of images what types of architecture are associated with different locations. The same thing can be said for plants, etc. So let's try something harder. So we change the words a little bit. Instead of Americas, we say North America and Africa. And it fails miserably. And so, okay, how does this become useful then? So we could just give up and we could say this model is useless, we can't do anything with it, or we could be hackers and we could try to come up with something better. So no, this is not correct. So what do we do? So is anyone familiar with the process of fine-tuning? I don't know how many AI nerds there are here, but essentially, we got one guy. Hey, there we go. So essentially, the idea of fine-tuning is where we have this foundational model that is kind of general purpose. And what we do next is we say, okay, I'm going to show you more images and text pairs that are specific to the domain that I want. So in this case, this is a system called StreetClip that was a paper that was precursor to Pigeon. And what they did is they took base clip and they said, okay, this is not very accurate at this domain task of geolocation. We're going to scrape, let's say, 1 million images from Google Street View, etc. And we're going to train clip by including, as you can see, the country, the region, and the city. And we're going to take that model that wasn't very good, and we're going to show it 1 million of these images. So we're not changing the underlying model really, we're just making it a little bit better at this task. So you guys saw what happened before where it failed miserably. Now if we take that same model and we show the same image and we ask the same questions, it correctly identifies North America. So you might say, I still don't get it. Okay, you've shown me a classifier. That's great. What does that have to do with GPS prediction? I can give it a couple words, but how does that get me from an image to an actual location? And the answer comes from the same paper that talks from Stanford that talks about, I don't even know how to say this, hierarchical linear probing. Has anyone ever heard of hierarchical linear probing? It's just a very fancy way of saying a binary search. So essentially what we do is we start with a hierarchy. So in this case, a hierarchy would be a region, followed by a country, followed by maybe a subregion, and then followed by a city. And so what that might look like is this. So we start with this graph, and this can be represented as a JSON document or anything that you want. But essentially, you have a representation of a hierarchy that starts with the top level of the world, and you go down by region. So you might say Western Hemisphere, Northern Hemisphere, Southern Hemisphere, etc., and you break these down. And what essentially this looks like, and what it looked like with the first version of GeoSpy, was I took a database of the world, and I think it was about 35,000 cities, and I broke it up into regions. So it was region by hemisphere, then it was by countries, subgroups, so African countries, then Southern African, etc., and then under the country, cities, etc. And so this was a very kind of hacky approach, but it did actually work. And so how does this get you GPS coordinates? So if you have a city, you can give someone the city center GPS coordinate. And that's all the original version of GeoSpy really did, is you took an image and it would kind of go down this hierarchy, this binary search, and it would say, okay, I'm going to start with Western Hemisphere, Southern Hemisphere, I'm going to rank them, okay, I'm going to go here, then I'm going to take a list of those subregions, I'm going to rank them, and it just went down the line until it hit the end and it terminated, and it had a city. Then it would do a lookup and say, okay, what is the city center for this city? And voila. So that, again, it didn't take any crazy, tracking someone's IP or reading the metadata. All it did is it took a zero-shot classifier and it said, this is where I think I am. So does this make sense so far? Okay, cool. So that's cool, but what if we want to do more accurate predictions than just a city center? Cities are great, but there are some very large cities, and if there's real-time events unfolding, we might want to know what street something is on, or what building that is. So Pigeon, which stands for Predicting Image Geolocation, took the original idea of this clip image encoder, and they said, okay, we can change our loss function, we can be smart about how we break things up instead of just this hierarchy. There's public data that describes pretty much, there's lots of geography nerds out there that describes every kind of administrative bounding, whether it's a county, a state, or a city. And we can essentially break these up into smaller and smaller subdivided areas. So you can see here, this is a city that's broken up into smaller and smaller areas, and you can get into basically as granular as you want. The smaller these subdivided geocells are, the more processing time it takes, but that's why we're focusing on this and working on this problem. And so maybe this slide should have been moved back, but if we take a look at this, we can say, okay, that's cool. Now, if we've got down to the last bit where we have a couple of cities, you can see this is ranked very highly as Albany. So this is Albany, New York, which is in America, which is in North America, which etc. So you can see. So that is the original version of the clip implementation and something similar to what GeoSpy used to use. And so GeoSpy Pro, or this new platform that we're working on for investigators, journalists, etc., this uses the kind of approach that I talked about for Pigeon. And so I think we can play this. Let's see. So here's a quick demo of GeoSpy working. And let me pause this. There we go. Any guesses where this is? Nope. Good guess, though. Nope. So, again, it's pretty low context. There's just a building. But if we run this through GeoSpy Pro, it's going to take about 10 seconds. Close. But no, no. And here we go. Okay, so we can see this is in San Francisco, and it's down to a very specific street. And so let's see how close we got. So we're going to pop into our street view. We're going to open this up, and we're going to look around, look around. That looks kind of familiar. I'm going to go a little bit down the street, a little further, and oh, does that look familiar at all? Oh, let's go back. And that's the building. So we were And so the most interesting thing about that is that, as I said, there was no metadata, there was no IP tracking. The uniqueness about that building, we were able to encode in some kind of higher dimensional space, and we were able to have an AI to say, this is where I think it is. And so, let me see. Okay, so this is cool. This is interesting. Does the future hold? So this is where we are today. Now, I'm going to talk a little bit about some of the edge cases for this. So I talked about before about clip and these different models. Some unfortunate things is that this approach for the most part only works with photos that, are taken during the day. And did anyone notice something about all the photos that I tested? Any trend? Um, that's true. They were all in the US. That's because that's most of my camera roll. Good, good, that's good. They are all buildings. And what else? Sorry? They are all in the day. So there's a couple things right there. So this approach works mostly with photos taken during the day, and it works very well with photos taken outside. Now, what if we want to geolocate photos taken inside? This is where privacy kind of comes in, but we'll talk about that later. Does anyone think that there is an approach that would work for geolocating photos indoors? The answer is yes, but I'm not going to talk too much about that. So, essentially, the challenges were, and this is kind of a problem that we're working on specifically for law enforcement, for people fighting against child abuse material, etc., is that when you're taking an indoor photo, you don't have as many context clues that are specific to a region. So when you're outside, there's a certain type of street sign, there's a certain type of architecture. Indoors, if I was just looking at this personally, I would just be like, I'm in a stadium somewhere. It could be anywhere. So it's a much trickier problem, but you can apply similar types of AI to solve this. I have a great demo that I can show people later if you're interested. I'm not going to put it up on camera. And so that's one thing that we're working on. The other problem that we're working on is, as we said, most of the training data that was used initially to build these AI is taken during the day. If anyone's looked at any of these things like Mapillary, Google Maps, in order to be useful, most people only post photos that are taken with good lighting. So these models are super biased. The last thing that I'll say is that I think it's really important, as you said, these photos are mostly taken of buildings. Buildings are great landmarks. They don't move. They're very specific. They have addresses. If you have just a photo taken somewhere in a forest, you might be able to figure out which forest based on the type of flora and fauna. But, if it's just a picture of tree bark or your feet in the grass, it's going to be much, much harder. You can still get a general region, maybe a country, but it's much harder to get something accurate. And so this shows kind of an example of that where we have, good call. So we have a query image over here, and we have a slightly different image, and we have a confidence score. And as the confidence scores goes down, the distance goes up, mostly. So the last thing that I really did want to talk about was kind of privacy concerns. So does anyone think that I've ever gotten questions about privacy with this? I put this thing up on the internet. Anyone can use it. It's free. If you go to GeoSpy.ai or you just Google GeoSpy, you could do it. Anyone think that there might be an issue with this? Yes, absolutely. So the answer is yes. Every day, I get emails with people sending me screenshots of someone's Instagram profile and saying, I want to find where this is. And every day I shake my head and I consider taking down GeoSpy. And then I remember one thing that I built in. So the public version has a failsafe. And the failsafe is it will only give you the city center for your predictions, the free version at least. If you're a police officer, investigative journalist, government official, etc., then it's a different story, but that's what the public gets. So the question kind of is morally is if you know someone's in a city, how much harm can you do? I don't know. My hope is that the OSINT community, including yourselves, will use this technology that's freely available to help, with your investigations and make the safer world. And it'll be a net positive instead of a net negative. So please, everyone, go to GeoSpy.ai, get feedback, use it, and don't let the bad people kind of be the only ones to use it. Let me see. So if anyone is interested, I can show you a live demo. Anyone is interested in airdropping me photos, I can do it out. Let me see. Actually, can I do this? Oh, I don't have Wi-Fi. That's okay. We could do. I can do it afterwards too. All right. I forgot to connect to the Wi-Fi. So if anyone's interested in seeing GeoSpy Pro or GeoSpy AI, you can talk to me, and I can set you up with a demo account, or we can kind of just talk. So I'm going to end a little bit early and say thank you, everyone.
Thank you very much, Daniel. I'm sure you will have plenty of questions. We have some questions.
And really quickly, if anyone has questions that I don't want to announce to the entire world, you can also email me. So dan@graylark.io. And I'm also available if you just see me walking around, just grab me and we can connect. I left some room for questions because I thought people might have questions. So questions?
You're going to be here all the day, I guess, and all the night, or?
Yeah, I think
I mean, guys, you can pay him some beers also to thank him for the tool that he made. So, do we have some questions or not? Yep. You see, there is plenty of questions. I have a lot also.
Thanks for your presentation. I just do a test, for example, 2 times with the same photo, and it gives me 2 different locations. It's a good country in Brazil, but one in Sao Paulo and one in Belém. It's still not this good city because it's a small city. It was the tricky things. My question is, because I do another test in the middle with a photo from Belém and he detected correctly, is it because he see my third research with the first photo and he adapted, or you have a link between my three research or not?
So I think, and correct me if I'm wrong, that your question was that does the last state, your last search affect kind of your future search? I think that was maybe your question. And so the answer is no. So to explain kind of the randomness, there is a component to GeoSpy that is non-deterministic, where there is kind of a random seed for some things. So sometimes if the confidence scores are waffling between, maybe it's like 49, 51%, it will switch. But this is a completely stateless system, so there's no database looking at like your previous search. So each search is independent of the last search.
Hey.
Thank you for the presentation. Whenever we're talking about AI, we always need to talk about the data. I assume that there are many more pictures of New York than some, remote village in Brazil. And so I was wondering 2 things. First, how to deal with maybe the bias in the volume of data that you give to the model. And second of all, you also mentioned, we're humans and places are quite different. But places also change over time. And I'm assuming, for example, in Ukraine right now, a lot of places don't look the same that they looked 2 or 3 years ago, especially in a context where we're using these tools to geolocate things in conflicts or war zones. How accurate the model is regarding these aspects, and how dependent are you on the quality of the data that you give it?
Exactly. So that is actually a great question. I think there were 2 parts to that question, so I'm going to try to answer them well. So the first part about data and bias towards certain areas, you're absolutely correct. So New York has a ton more photos than, some village in Africa or small village in China, for example. And so how do we deal with that? So that is actually one of the main research questions that we're working on at Graylark is we look at how do you take lots of data. So most places on Earth do have photos somewhere of them, even Antarctica, etc. With this kind of advent of the mobile phones, people just love to pull out their phones and take a selfie here or post a photo there. They feel special because they're in some small village in China. Humans tend to like to share things, which is great. So part of the issues is one, how do you kind of discretize your data set and say, okay, well, I'm not gonna only be able to geolocate in New York. I'm going to be able to take into consider Africa. So you have to weigh your data and you have to clean your data in a way and train in a way that you're not creating this huge bias. And that's a huge problem and something that we're definitely working on. And then I think, what was the second part of the question?
Yeah, it was about war and places changing aspects.
Yep, exactly. So I don't know if you guys are surprised. We did get lots of reach out, specifically regarding the Ukraine conflict. Lots and lots of interest there. And so that's another question that we got a lot is how do you update your models and your system so that we have a building that comes down or something changes, is deformed, and we still associate it with the same place. The assumption that buildings are static is right most of the time, but in high conflict areas or areas that tend to be, under constant development, how do you update it so where your system still recognizes things? So we're doing research in the area of I call building deformations, where you're able to still represent a building the same way, even though it's deformed, by looking at kind of changing the way you weight the characteristics of that building. It's definitely very tricky. And then the other thing is using these data stores and databases that allow us to do. Are you guys familiar with RAG, retrieval augmented generation? It's a way in where we have a base model that understands these types of features and then is able to look at a database that is ingested live. So it's kind of like we have a way to, instead of retraining a model, we can kind of update a database of buildings and images so that we can kind of replace old things without having to retrain models. Because retraining AI models is very expensive and takes a long time. I think that answered it.
Hello. Thank you for your talk. Can GeoSpy be integrated to other OSINT tools or platforms?
Absolutely. So that's a great question. So I forgot to mention this, but we have, this is now kind of my full-time job, so we have turned this into a API. So it's available for API. There's two different versions, actually. Let me do that. So there's an API that anyone can use. If you're interested, just follow me and I can, or email me and I can give you some free credits to try. There we go. I think that's better. It's the Russians. So you are more than welcome to sign up. If you look up dev.geospy.ai, you should be able to find it. There's free credits, and I can give you more if you need some. And we have integrations. I think we might be doing an integration with Maltego, which should be really interesting. And there's a couple other integrations that we have already. So feel free to ask me. And the models are going to keep being updated, and we're going to have more features like building recognition, building to address prediction, etc. Those are all coming out, and then the GeoSpy Pro will be launching soon, which will let you use your account as well as have an API. So if you don't want to integrate it into a tool, there's a visual investigation platform, and if you have another tool, feel free to reach out.
Yeah, hi. I have two questions actually. The first one, at the beginning of the day, what motivated you to start and develop this program? And the second question, what's your ambitions for the future? How do you think you're going to make it better?
That is a great question. So what motivated me to build this was, I'm a hacker at heart, so I don't like people telling me no. So the fact that they didn't publish their code, I was kind of mad, and I was like, well, fuck you guys, I'm going to figure out how you do it. the funny part is those guys now who wrote the original paper are advisors, and they're the sweetest, nicest guys ever. And I came into it being like, yeah, I'm gonna like show you guys, and they're like the most nice German, like, cool dudes I've ever met. So I felt kind of bad afterwards. But we've met finally, and I visited them on their Stanford campus, and it's been awesome. So that was a motivation, and then my ambitions. I mean, it's still every day I wake up and I'm like, wow, am I actually doing this? So again, 6 months ago, I was working as an AI research engineer, and now I have this company. We just closed our seed round. We have great investors like Recorded Futures Intel Fund, Scope Now. I don't know if you're familiar with those. And it's been really exciting. So, I mean, my ambitions are to build tools that actually help people answer questions, not just OSINT, but, marketing, this type of threat intel type stuff. So I just want to, it's cliche, make the world a safer place, but build tools that empower journalists and fraud investigators to actually make their jobs easier. As the world kind of grows and becomes more and more image and video data driven, TikTok, etc., the job of analysts is going to get harder and harder because we've relied on things and tools like Google to do lexical search. But if you just say, hey, where was this image taken? Google doesn't do that. And so being able to take these type of visual medium, audio, video, images, and make them searchable, understandable, and fast for analysts is kind of our goal. So I hope that answers your question.
Yeah. Здравствуйте, у меня есть вопрос. No, sorry for the joke. What happens if I take a picture in the suburbs of Saint-Denis in front of a Nike store with two cars, US cars with US plates?
So that is a great question. And so I think what you're asking is if you are somewhere that has conflicting evidence, for example, the US plates or an American flag, but you're actually in Britain, what's going to happen? And so the answer is kind of twofold. So we had lots of people red team and trying to trick our AI, and there are some very interesting things that happen. So if there are things that are just kind of accidental, maybe there's a US plate in Canada, that's something that's common, and the data usually tends to tell the story itself, where it can usually figure out where to weigh the different features. So if it sees a certain type of tree and a license plate, it's like, well, I've seen this before in this location. If it's people purposely trying to trick things, there are tricks you can do to weigh the kind of what you're interested in. So I think I showed this before. Sorry to go back. There's too many slides. You see these types of highlighted things. You can have the AI show you what is influencing its decision and what it's weighing. And as part of our investigation platform, we want to have users have the option to almost have a brush to say, like, okay, ignore this part. Because humans are the best arbitrator of truth. And this is never meant to replace humans, but it's meant to aid humans. So if you think something is weird, you maybe take a little brush and scrub it away and say, ignore this part, and it'll change the prediction. And the easiest way to do that right now is to crop something out on GeoSpy, and that can wildly improve accuracy. So I hope that answers your question.
Hello, thank you for the presentation, and also thank you for making this tool available, because I remember reading also on Python and not being able to practice it. So thank you for that. I have a very classical question, and sorry for this, but when do you think like the machine's going to beat the human? Because I remember reading like a paper from Bellingcat. It was mid-2023, I think, and they mentioned like tools using AI to geolocate places. I think it was based on Python, and they said for now it's not. It doesn't beat the best investigators, and they mentioned also those places, blind spots of AI.
I mean, I'm biased, but I would say we're already there. So I think that for the most part, a lot of the tools that people use, something like Google Lens, for example, is actually an implementation of AI. Just a person, even, I don't know if you guys are familiar with Rainbolt, but that's maybe one human that can go head to head with AI. Fun fact, though, there is a video competition of Rainbolt versus Pigeon, and he loses. So it might be a question of time. I think on average, the machines now, and again, I'm biased, are better. The things we have in private are much better than any human can ever be. And that's just because the AI can look at, a billion photos and understand things humans could never. Now, there will always be niche knowledge where someone notices some random thing by chance. This street sign is faded and they only, change street signs in this location every 5 years. So some really kind of niche thing that might be skipped in training. Those still exist, but not for long. So to answer your question, I think machines are better, but not the public version of GeoSpy to prevent stalking.
So thanks again for this very nice presentation. I was wondering, this must been a massive data set you got there to train your eye to do this kind of thing. Do you have any comment on where you got these data and how you sanitized them?
Sure. So the most interesting part is the original data set was only 4.7 million images, which is kind of the crazy thing. So the research and data set was, again, pioneered by Dr. James Hayes, who is also an advisor of us. Anyone can download this image data set if they want. It's a subset of the YC medieval placer data set, which is about 100 million geotagged images. And we have our own, I'll say, unique methods of data collection now, where we've far, far surpassed the 4.7 million images, but that's reserved for our kind of law enforcement, et cetera, or journalist system. I can't talk about how we collect those data because there's a lot of different companies who like their data and might not like what we're working on, but too bad. But to answer your question, the initial data set was very small. And if you're interested, I can always show you kind of offline how that works. But if you look up Street Clip, there should be a place that talks about the type of data. And it was all from Flickr.
Once again, thank you for your enriching presentation. I got a question about season. We often use trees and leaves to locate trees in the world because we know that tree doesn't grow everywhere in the world. So as a OSINTer, it's a really interesting topics. And how your model deal with all the seasons and most the climate change that go the faster and faster and obsolete the dataset you ever made on the picture you store in your dataset. So are you transitioning to a continuous real-time fine-tuning model, or do you have some plan for the future on it?
Yeah. So the nice thing right now is that humans tend to like to take pictures kind of all the time in most seasons. So the data typically, will have multiple images in a similar location from a different angle at different times of the year. And that's really nice. Talking about continuous learning, yes, we do have data pipelines that we're building, which we take in new data and we start retraining. And I talked about before having these database lookups that don't require this type of retraining. So yes to all those questions. That is a super important part because, as I said before, things do change, wars, development. I mean, if you took a picture of Dubai 20 years ago and you take it now, it's completely different. So that's something that we're working on actively and just building up big data pipelines. When I started this on Reddit, I never really envisioned that we would, I didn't really know what a petabyte of data looked like until I got my AWS bill, and I was like, oh, that's a lot of data. So those are things that we're building and hopefully will add and increase accuracy over time.
Shorter question this time. Does the model take humans into account in the pictures? And does it learn perhaps to make some inferences, for example, that this place is where I find people that look a certain way, and then that, could bias the model a little bit if it sees humans in it?
Absolutely. So if you take a picture of someone of a certain ethnic type and you just put them against a black background or a white background, and you say, where is this? The funniest thing is this actually tends to work really well and too well. So there are different ethnic groups if you look at India, Pakistan, et cetera, there are, people tend to be from different places, and we've had people be like, I took a selfie and it told me my exact city, but that's kind of a false That's not really how the AI is working. There tend to be people in more population dense centers, and the default is if I think this person is in China, I'm just going to stick it in Beijing, and someone's like, oh my God, it found me, I'm in Beijing. But that's not, the AI isn't really like looking at, the public version is not looking at like your face and matching your Facebook profile. That's not how it works. That's just kind of an accident. And it is biased towards certain things, but I think that's almost a good thing because, as I said, it's kind of that balance of looking at the features and looking at the people and understanding human characteristics of like people here, architecture here. It's just one clue, but it's not an ultimate determination factor thing.
I think one of the easiest geotech pictures are from like Google Street View and other such tools. So can we say that as long as the building is on Google Street View or a similar tool, that the GeoSpy is most likely to geolocate it correctly, or is it not so?
So I won't mention specific companies who love their own data. I will say that streets tend to be photographed often by different companies who do street mapping stuff. So if you're on a street or you're taking a picture of a building, I would say there's more than high likelihood that it will be in our data set somewhere, but not because it's from a specific company.
Do we have other questions? Sorry. Nope. Well, please applause Daniel. And, of course, welcome in France. Our sponsor, Epios, offers you that bottle of champagne. So I hope it will be useful and it will not demotivate your developer from the new version of GeoSpy.
Thank you so much, everyone. I really appreciate it.
Thank you very much.